think we'll go ahead and start now. All right, everybody, thank you again for joining us for today's campfire. The title is JSON-RPC versus SOAP versus Apache Thrift. Battle Royale. Yes, we tweaked the title just a little bit for the invite. But anyway, my name is Abby Andrews, and I will be your host today. Today, our Director of Engineering, Oliver Nelson, will be reviewing these protocols in detail with us, JSON-RPC, SOAP, and Apache Thrift, and he'll be talking about how to select the right one for your particular application. So we all know that the framework that you choose in your design phase is critical, right? So it can make a very big difference in your API development. So we want to help you choose the right foundation from the start. And we're also going to talk about how Mertech's Evolution API server can help you expose your APIs using all of these different protocols. So Oliver will go over that in more detail as well. But before we dive in, just a couple of housekeeping reminders. Right now, all attendee lines are muted. So just like our other campfires, we want this to be as interactive as possible. So throughout the presentation, I encourage you to send in your questions via the console, and we'll go over them during our Q&A time at the end of the presentation. Also, this campfire is being recorded, so if you don't want to take notes now, that's fine. You can always play back the video later, and you will get the link to the recording via an email by later today or tomorrow. So without further delay, I want to pass it over to Oliver. Oliver, you want to start?
Sure. So welcome, everyone. Today, we're going to be talking about 3 architectures commonly used with APIs. We're going to take an objective look at these protocols and try to help you figure out which protocol is right for your application. So most of our time is actually going to be spent looking at these protocols. So first, we're going to define a few terms. We've talked about SOA before, service-oriented architecture. A microservice is essentially a form of SOA. Now, all of these architectures are referred to as microservices. Thrift, JSON-RPC, and SOAP all are considered microservices. A microservice encompasses the idea of having a small independent service that's specialized for a given task. So, for example, you might have a small service for retrieving and posting messages to a forum. But that service that does that message posting and retrieval might be separate from another service that's offered on the same website even that allows for person-to-person chatting. So this idea of these very independent specialized services is the idea behind a microservice. The protocols we'll be going over, SOAP is the first one, and many of you may know SOAP as Simple Object Access Protocol as an acronym for that, but that's actually no longer the case. As of SOAP version 1.2, I believe they kind of got rid of the acronym entirely, and SOAP is essentially a brand now. It no longer stands for that just because it's encompassing a bit more nowadays. So SOAP is just SOAP now. And of course, SOAP is a XML-based protocol for exchanging structured information. And we're going to dig into it a bit more. JSON-RPC is pretty self-explanatory if you know the acronyms it's made up of. JSON, JavaScript object notation, refers to a way of representing data in native JavaScript, and RPC is a remote procedure call. Now, JSON-RPC is actually kind of based on XML-RPC. They share a lot in common. XML-RPC is a protocol that, interestingly enough, many people think that XML-RPC came before SOAP, but in fact, XML-RPC was based on a draft of the SOAP specification. So technically, JSON-RPC has its roots in SOAP, oddly enough. So just an interesting fact there. Thrift, on the other hand, is more than just a protocol, and we'll go into that in more detail. But essentially, it's an entire framework for cross-language services that's meant to be very scalable. We're going to go over each of these protocols in more detail, but as a brief overview, we created a little cheat sheet here that kind of gives you the 20-word overview of each of them. SOAP SOAP's saving grace is what are called WSDLs, Web Service. WSDL stands for Web Service Definition Language, and the actual document is referred to as a WSDL. A lot of people call them WSDLs, and it defines a contract between the client and the server. Many tools generate code bindings from this WSDL. Now, SOAP has been around since the late 1990s. In comparison, the original spec for JSON-RPC was released in 2005. JSON-RPC is simply a specification that defines a certain way of making HTTP post calls using JSON. So JSON is very simple from that standpoint. The big downfall of JSON is that it doesn't have something like a WSDL available for it. It doesn't have this description language or a definition language of any sort. And we're going to talk about that a little bit more later. Apache Thrift is much more than a protocol. It includes transports, an interface definition language, a code generation tool that allows you to create bindings to a Thrift API in many, many languages. So when we think about what each of these are, that's essentially an overview. So SOAP was that XML, structured message transmission, JSON-RPC, remote procedure calls, no service description, and Thrift includes a whole bunch more, and we'll dig into that. One of the first questions that normally gets asked by developers when they're looking at various RPC mechanisms is which one is the fastest. That's always a primary concern, although it's often not the only concern. So we created a little graph of the results that we've seen analyzing these protocols. Now, before we look at the results, I need to preface this with a couple of details. When we look at the speed of a protocol, in general, we're looking at what we're looking at is how many CPU cycles it takes to parse the actual payload and whatever overhead there is associated with the transport. So, for instance, in relation to HTTP as a transport, there's some time required for an HTTP call to be set up, and some of that overhead time can be avoided if you were using a socket-style connection that didn't have an HTTP protocol sitting on top of it. What isn't factored into the numbers we're going to look at is the actual time it takes to execute your code. So really what this graph is quantifying is what is the overhead related to a given protocol and transport in comparison to other protocols and transports. So first up we have SOAP. SOAP is actually a pretty CPU-intensive protocol to parse, to use, because it's XML-based and there's quite a bit of work required to get the data out of XML. So in this case, we can see that in general, on a decent machine, we're looking at a base speed of somewhere around 500 calls per second is a very reasonable number to see on a modern server that was released in, let's say, the last 2 or 3 years. We can go higher than that, but that's kind of the scale of the number that we're looking at. In comparison, JSON-RPC is in the range of 5 times faster than SOAP. With JSON-RPC, we have a much simpler structure to our actual message that's going over the line that's much easier to parse than SOAP is, and it's smaller, in fact, and those things make it less CPU intensive, and there's less time being spent actually transferring your data, and so we're able to handle more theoretical calls per second using JSON-RPC. Now, where this really gets a little bit crazy is when we look at Apache Thrift. Let's see how it compares to these other 2 protocols. Apache Thrift is a lot faster. We're looking at 10 times faster than JSON-RPC, and in fact, This number here is very conservative as to what a single Apache Thrift server can handle. If you look at some of the testing that we've done internally, we've beaten this number by quite a bit. We've seen easily between 30 and 40,000 calls on a decent server, but conservatively speaking, 25,000 I think is a safe number to use here, and a fair number from that standpoint. So why is Thrift so much faster? Well, we're going to get into it in more details a little bit later, but basically it's related to the format of a Thrift message. It's a much smaller message being sent over the line, and it's optimized for computers to read. And so that allows Thrift to really pull away from the others when you look at the amount of time it takes to process these messages. So that means that when you're considering building an API, whether it's going to be used internally or as a service, if you're looking at SOAP, especially, you really need to consider how much actual communication is there going to be between the client and the server. Because if that communication starts to increase very quickly, the overhead of using SOAP as your protocol can really bog down your server. With JSON-RPC, that's less so. And with Thrift, essentially, that's not much of a worry anymore. We're dealing with numbers that are so large that you can almost just forget about that aspect of the equation for your application because Thrift is so fast. Next, we're going to look at the advantages of each of these protocols and the disadvantages as well. First up is SOAP. One of the big advantages with SOAP is that it's an entrenched protocol. It's used all over the place. Although it tends to be prevalent on large commercial services versus consumer-oriented services. So for instance, you may see it in an enterprise resource planning system or a large CRM, but it's less likely to see a SOAP interface on, let's say, a store that has an API that you can use to purchase into their store. It's much less likely that you're going to see a SOAP interface there. So it does really have its market that way. Although SOAP can technically work from a web browser, it doesn't work all that well. That's another one of the issues with SOAP. I've used SOAP from JavaScript in a web browser myself. It's just not a very pleasant experience. It's not impossible. It's just not something you really want to do. And the reason there's an issue there is that XML in a browser is something that doesn't work very fast to begin with, and then you're trying to parse that XML and process it with JavaScript, and it just doesn't make for a good scenario. Another issue with SOAP is that it's a very heavy protocol. As you can see, we've got an example request and response here, and there's quite a bit of data, both in the request and the response. I mean, we're dealing with at least a couple hundred bytes here of data for a very small SOAP request. And same thing for the response. There's lots of information there. SOAP requests are very verbose that way. And that's a good thing from the standpoint of having a contract between the client and the server, but it's a bad thing from the standpoint of bandwidth used and again, the processing time associated with it. As you can see, it's also not very human readable. It's kind of the in-between protocol that way. You can certainly look at it and tell what's going on. So maybe it's readable, but it's not human writable, that's for sure. And in many cases, when you use a SOAP interface, really you can kind of feel the age and the history with it. The interfaces to it a lot of times are synchronous interfaces, and so sometimes SOAP calls can feel especially slow because of that. So, but on the plus side, we do have the fact that it's used widely in the commercial world, and the fact that it defines a very tight contract between the client and the server. And it also has all of these other capabilities that are defined for it. There's this whole series of what are called WS- features for SOAP, and those various features define all kinds of things from authorization to authentication to token handling, just all kinds of things in there. Now, what I found is that although there are defined capabilities, very few SOAP services actually use those, so something to keep in mind there. In comparison, JSON-RPC is really quite simple. As you can see, it's human readable, and it was designed for the web, where SOAP really came along very early in the web's life and wasn't used nearly as much on the web. The requests are significantly smaller and simpler than an equivalent SOAP request. So in this case, we're looking at the same sort of request to get a stock price. And you can see just how small a request is and how small a response is in this case. A request is something like 90 bytes for the same thing, whereas it was over a couple hundred bytes on a SOAP request. So a very small, easy to read, easy to write request and response. Additionally, JSON-RPC requests can be made from pretty much every popular programming language out there. It's a big advantage. Whereas SOAP has it has a fair number of languages, very business-oriented languages that support it. But for instance, even something like Python, the SOAP support in Python is actually very poor, whereas JSON-RPC support is very strong in most of these modern scripting languages and other popular languages. Although JSON-RPC as a standard itself may not be as widely used as SOAP, since it is just a simple form of JSON, even if your environment doesn't specifically support JSON-RPC, if you can read and write JSON, you can make JSON-RPC requests. JSON-RPC is simply a format of putting your JSON in. There's nothing more to it. So if you're working in a language where you can post JSON requests and parse the responses, even if you don't have specific support for JSON-RPC, you actually do. And as you can see, the format is very simple to follow. On the downside, with JSON-RPC, of course, there's no descriptor standard, and you'll notice I wrote kind of there. Well, there has been some work done in this area. None of it has really taken yet, and so people are using various solutions. There's a standard called JSON WSP. There's another standard called JSDL, which is very similar to WSDL. And there's then other standards that are really meant for RESTful interfaces like Swagger and YAML, and those can also be used for JSON-RPC, although they're not ideally suited for it. So I've even seen people, and one of the things that we do internally is we use WSDLs to help us define what our JSON-RPC looks like, since, in fact, they are quite compatible from that standpoint. One of the other things that has affected JSON-RPC is its name. When you look at SOAP or Thrift, the names are simple, easy to remember, and that really does affect whether a certain protocol gets accepted widely, and JSON-RPC is just not a catchy name. So I honestly think that's one of the reasons it hasn't grown as much as it could. With that being the case, though, JSON-RPC has made lots of progress in the last 24 months or so. If we look at where JSON-RPC was 2 years ago, if you looked on the Wikipedia page for it, for instance, you probably saw somewhere around 12 to 15 implementations, which is fairly small. I mean, it's decent, but not spectacular. If you look now, you're going to see 40 to 50 implementations of JSON-RPC. So a lot of people are using this now, and a lot of businesses have taken to JSON-RPC. Thrift, on the other hand, is a bit of a different beast. When we talk about Thrift, we're dealing with an entirely binary protocol. It's not something you can read, but because they provide these code generators to bind to an API, you're not supposed to actually read what's going over the line. A Thrift version of our request to get a stock price takes up well under half the number of bytes of a JSON-RPC request. Thrift is a really good solution for mobile because it's such a simple format and a small compact format. Parsing it is really easy on these ARM-based processors that we see in mobile devices. It also means that less bandwidth is used transferring the message between the client and the server. The code generators that are the code generator that's provided for Apache Thrift can create bindings in C, C++, Java, Python, PHP, Ruby, Erlang, Perl, Haskell, C#, Objective-C, JavaScript, Node.js, Smalltalk, OCaml, Delphi. It's pretty broad that way, and in fact there's more languages in the works even than that. Those are just the well-supported ones. One of the other nice things about Thrift is that you have the ability to choose between a stateful or a stateless connection. So you can use an HTTP connection that is essentially stateless, or you can open a socket connection for Thrift, which gives you a long-running stateful connection. And just recently, there's been some progress in the area of using Thrift in web browsers. I mentioned that as a negative for Thrift here, that it doesn't play well with web browsers, but that's something that's changing, and we're going to talk about that a bit more in a moment. So really, the negatives to Thrift are very minor. It's a much younger protocol. It's a few years younger than JSON-RPC is, and so it hasn't picked up quite as much steam as some of the others. But with its foundations with Facebook has kept improving Thrift. They've done some releases. There was one last year where they added quite a few features into Thrift that they were using internally, and the Apache Foundation has done a great job at really growing the Thrift community. So, this is a protocol that's an up-and-coming, actually a framework that's up-and-coming right now and has really very few downsides to it. And so we're going to talk a little bit more about the use of Thrift on the web, though, since really if you're building web applications, that can be one of the biggest concerns we have. In general, even though Thrift supports HTTP, it's not normally consumed by web-based applications. Native mobile applications normally have been the users of Thrift over HTTP, not these web applications. And the reason for that is because the binary protocol didn't work very well in web browsers. That is until recently. Thrift has been making inroads in this area specifically. There's been quite a bit of open source development on using the binary Thrift protocol directly from JavaScript on the web. And this is a really good thing. As you know, the web has gotten bloated over recent years. We've had lots of stuff in online blogs and various other spots about how these websites are just getting bigger and bigger, consuming more resources to load them onto your browser, and kind of ruining the mobile experience in many cases. Something like a small Thrift binary protocol on a web-based application could really help slim things up a bit. But even more interesting than this development is what's being done in the area of making binary Thrift calls over WebSockets. In case you're not familiar with WebSockets, they're basically a full duplex socket connection that's initialized with an HTTP upgrade request so that they're compatible with HTTP servers in some fashion. But they're basically just a socket connection, and they can be used from modern web browsers, and they give you the advantages of a socket connection, such as stateful and persistent connections right in a web browser. That's not something we've had in the past. And so this is a new area for Thrift, but one that opens up quite a few doors for things like doing binary uploads using an API rather than the older methods of form-based uploads or Flash-based uploads, which were popular, unfortunately, for quite a few years. So that's a huge advantage to this idea of binary thrift over WebSockets. Additionally, by having this stateful connection, we have this very low latency connection as well between the browser and the server, and this allows for things like chatting applications. Normally we would use something like WebSockets, and being able to use binary thrift in this case makes the transfers even smaller. Or for things like games, for instance, it opens up quite a few possibilities. So this is a very interesting development that's occurring in Thrift, and really what it's doing overall is it's expanding the places where Thrift is a good solution for you. So that's something to keep in mind, that this is a framework that's growing to encompass more of the types of use cases that people have right now. Thrift's biggest disadvantages are related to the fact that it's not human readable, and as we mentioned, right now it's not very popular on websites. But if you're writing an API that's going to be consumed internally, for instance, such as maybe something where you have your application in C# or VB or whatever the case may be, and you want to access some of that business logic from PHP or Python or whatever, Thrift is super fast, and of course with the code generator, the bindings are written for you. If you're planning on writing a native mobile app, Thrift is also a great choice, since it not only reduces the amount of data being used, which will make your app faster, it's also faster for, as we mentioned, these ARM-based processors to parse, and that can make it an interesting choice for things like these little handheld barcode scanners and RFID scanners that need to communicate with an inventory server, for instance. A lot of times the constraints on what you can develop for those devices are really quite great from a memory standpoint and from a CPU standpoint, and so Thrift fits in very well there. JSON-RPC is your solution for web-based single-page applications. And really, when you think about that, you may think of Angular or Backbone or something like that. Consuming a JSON-RPC API is super easy to do. Although you don't get code bindings like you do with Thrift, JSON-RPC is so simple to create and understand that it doesn't much matter. And of course, SOAP is not going away anytime soon. It's, like I mentioned, deeply ingrained in many industries, including banking and insurance. And SOAP is very often the only protocol that these businesses are willing to speak. But if you have a choice and you're building something new, using one of these other two protocols, JSON-RPC or Thrift, is really your way to go. So after all of this, what if none of these protocols fit your situation? Maybe you want the advantages of Thrift, but you're still tied to using SOAP for other reasons. Well, we've got an app for that. Our Evolution server can help with just such a situation and many more. With Evolution, you can serve your API via SOAP, JSON-RPC, and Thrift simultaneously, the same API via all three protocols. Also, we provide a testing interface built in, and you can access your API from nearly any programming language, anything that can access SOAP, JSON-RPC, or Thrift. So you have a broad selection of languages if you want to bring in other resources, for instance. Also, Evolution is meant to be scalable and blazingly fast. Those tests that I showed you earlier were actually based on our Evolution server, which is in most cases the fastest implementation of each one of those protocols that we've been able to find. So if you're looking at developing an application that uses a SOAP API and you're thinking of just using what's natively available, Evolution is still a good choice for you, because in most cases we beat that native implementation even. So something to keep in mind there. And we designed Evolution to be used not only on mobile application stacks, but also desktop stacks where maybe you're communicating with a legacy server, and also server-to-server-based applications. So we've kind of had all of these use cases in mind. Evolution also includes server management tools, which is something you don't get when you use the native provided interfaces. We provide you with tools to manage pools of applications, to set up what protocols are used and how big the pools are, and we have logging into the event logs for things like that. So there's a lot of the management, restarting dead processes, all of these things that normally you would have to build out other parts of, you'd have to build custom pieces for, we have built into Evolution. So, and of course, the main thing here is that because Evolution can connect to a lot of these legacy application stacks, you can keep your existing code base in place and be able to leverage that prior investment. So that's really what we wanted to talk about here, but before we get into our Q&A portion of this, we're going to do a poll, and I'm going to turn this over to Abby to give us our poll.
Okay, thank you, Oliver, for all that valuable information about API protocols. Folks, I hope you found all this information valuable for your use case. I've received a couple of questions already. We'll go over them in a couple of minutes. But right now, we want to make sure that we provide you with more valuable topics like this campfire today. So we just want to do a quick poll, kind of to just get a gauge on what kind of topics you're interested in learning more about. So right now in front of you, you'll see a quick menu there. If you could just pick and choose, you could select all that apply. I'll give you a few minutes to make your selections, and I'll close the poll and share it with everybody. So go ahead and do that right now. Okay. Great, okay. Okay, I'll close the poll in just a couple of seconds here, and I'll share it with everybody. Okay, looks like mobile application, Oliver, is very popular.
Yeah, look at that.
Wonderful.
So the Microsoft IS versus Apache is also an interesting topic too. That we're planning an upcoming campfire on that as well. So we'll keep these things in mind.
Absolutely. Also, just a reminder: if you go to Mertech.com, you'll see a link to our YouTube channel. So you'll see a whole library of different topics as well on our past campfires in our YouTube channel. But I do have a couple of questions that came in, Oliver, so if you're ready.
Sure.
Okay, somebody asked, you didn't mention REST protocol. How do these protocols that you talked about today compare to REST?
So REST is also an HTTP-based protocol, and it really has its foundations elsewhere. It's based on the idea of using the verbs that are included in HTTP requests as the foundation of what's normally a CRUD style interface. So you have a get verb, a put verb, patch verb, a delete verb, all of these things that are built into HTTP, and REST makes use of those. One of those verbs is called post as well. And JSON-RPC, for instance, uses just the post verb of HTTP. And when you look at REST, although there are some specifications for its implementation, many APIs implement REST in their own slightly different flavor than each other. It's not quite as standardized as some of these other protocols are. So that's one of the differences. The other big difference is that REST is trying to expose an entity rather than trying to expose a functional interface. So with REST, you have a get verb that you might use to retrieve let's say a customer, and so your path, your HTTP path is going to include information about that customer that you're wishing to retrieve, and you're getting back this entity. Whereas in these other protocols, SOAP, JSON-RPC, and Thrift, you're sending a message to a server and you're asking it to run a function, and maybe that function is going to return you data about a customer. But that's a conceptually different thing. And so although people implement REST APIs to do things that have been done using remote procedure calls as well, they do have that difference conceptually that sometimes changes the way you use things. A lot of the same, but REST in general uses JSON, for instance. So a lot of the same things apply for REST as they would for our JSON-RPC examples. So the speed, for instance, of REST is going to be very similar to what you would see in a JSON-RPC implementation.
Okay, thank you, Oliver. I think you might have mentioned about JSON, plain JSON compared to JSON-RPC, but can you touch a little bit more about that? Somebody's asking as well, the difference between JSON-RPC and JSON.
So when there isn't a huge amount of difference between the two of them. When we're talking about JSON-RPC, we're talking about taking JSON and just formatting it in a certain way, having certain items defined in our data. So for instance, if we were to go back and just look at the example for JSON-RPC, that is JSON in our request and response. That's completely valid JSON. The only difference is that with JSON-RPC, we're saying, hey, look, we're going to have a version string at the top here that specifies 2.0. Rather than just sending data and maybe using the URL to specify what we want to call, we're going to have a method parameter in here that specifies the name of the method to call on the server, and then we're going to have a dictionary of parameters where we specify those things, and then kind of the oddball out is the ID, which is something that was kind of picked up from XML RPC that allows results to come back out of order and allows you to know what request that result is for. So it's kind of that one's a little bit more specific. But this is JSON. So they're very similar in that fashion, which means that if you are using JSON right now, you can use JSON-RPC with very little work, and it makes you hold your implementation to a little bit more well-formed standard. Is essentially the long and short of it.
Okay. Okay, great. Thanks, Oliver. So if anybody else has any questions, please feel free to email that in through the console. But if you think of more later, you can also give us a call or email Oliver directly. We'd love to, if you want to know a little bit more information about our Evolution API server, we'd love to walk through the product with you. But you can email us at sales@mertechdata.com or oliver@mertechdata.com or mertech.com. Then we will definitely reply back to you as quickly as possible. So it doesn't look like we have any more questions. So we will go ahead and wrap it up. But I want to thank everybody again for logging in today. Like I said, you will receive a follow-up email with a link to the recording. So we'd love it if you could share this video with your colleagues or your online communities. We always love being shared throughout. But also, if you can take a few seconds to fill out the webinar survey that's going to pop up as soon as we close the session, we would really appreciate your feedback. But anyway, hope to see you at the next campfire. Thank you again for logging in today, and enjoy the rest of your day. Thanks, everybody.